attending this session. I'm Peter Carter with the Climate Emergency Institute. I have my colleague here, Paul Beckwith, and we have Regina Valdez as well. These sessions, these media reports, we're giving the latest news on the climate emergency, and this one is the Arctic climate emergency. I'll just say a few things before handing over to Paul Beckwith. Arctic feedbacks and tipping points threaten our survival. A quote from Antonio Guterres, the UN Director General, pointing out that climate change is an existential threat to most life on Earth, and particularly humanity, and that's very much because of the Arctic. I have to make a mention, of course, of the big, awful, terrible news yesterday that 2019 was yet another year, a record year for global fossil fuel carbon dioxide emissions. Absolutely, absolutely terrible, because all of the science has said for many years that by 2020 they must be declining. So this is the Global Carbon Project. You see the emissions, CO2 emissions from 1990 there up to 2019. And if you take a look at their record from 1960 to 2016, it's even more dramatic that we are on a route to planetary catastrophic collapse. And again, that's very much because of the Arctic. And so just to show one of the many images, this is from UNEP, that we have to decline our emissions in order to survive by 2020. And the science has been definite on that for years. I'll pass over to Paul.
Thank you, Peter. So I think it's becoming pretty clear that, the Arctic is changing faster than just about any other part of the planet. And many years ago I came up with the phrase, what happens in the Arctic doesn't stay in the Arctic, because Arctic changes have global effects and global implications. So first and foremost, we have the Arctic temperature amplification effect. So just as we mentioned in our last press conference, this year we're heading to have an average annual temperature increase globally of 1.1 degrees Celsius relative to the 19th century. That equates to 1.4 degrees Celsius increase relative to the pre-industrial baseline year 1750, which is what the 2 degree and 1.5 degree Paris numbers are based on. They're relative to the pre-industrial levels. So, and in fact, when we had a strong, powerful El Nino in 2015-2016, in February of 2016, for that month, we were 1.6, almost 1.7 degrees Celsius above the pre-industrial for that month. So, but now we're for a whole year, we're approaching that 1.4 degrees Celsius number. Why is the Arctic amplifying temperature so much compared to the global average? Well, the Arctic is a very high reflective place, because snow and ice reflects a lot of sunlight. So the sunlight hits the snow and ice and reflects back up into space. But as we lose the Arctic sea ice, we're replacing that bright white ice with dark seawater. As we lose and that's decreasing in September's at a rate of about 12.9% per decade. Snow cover on the land areas surrounding the Antarctic is decreasing at 22% per decade for the spring months, so May, June. So making the Arctic much, much darker. And because the Arctic is much, much darker, it's absorbing all that additional sunlight and it's warming like crazy. So this, like I said, has global implications. So the jet streams exist on our planet because we have a cold pole and we have a warm equator. So raise the temperature significantly of the pole and you'd reduce the temperature difference to the equator, and that means the jet streams, the physics of it means the jet streams have to slow down and become much wavier. And when they do, they've been doing that, and thus the incidence of extreme weather events, the frequency of occurrence, the severity, and the duration of extreme weather events has greatly increased. Another thing that happens is, as the jet stream becomes very, very wavy, the troughs of the jet stream go down as far as the equator, actually, and the jet streams even combine with jet streams in the southern hemisphere. And the ridges of the jet stream that carry heat and dryness north extend up as far as the Arctic in the middle of the winter. Okay, so we can have the North Pole above 0 degrees Celsius in the middle of the winter, complete darkness, because the jet stream ridge has carried that heat up there. So the other thing that happens is, think of the jet stream and what it circulates around in the northern hemisphere. Okay, it circulates around the North Pole, a little bit offset towards Greenland, but basically, if you take all the cold area in the Arctic and kind of calculate the center of mass of it, or the centroid of it, it's just south of the North Pole. Now, what happens in a world where there's no sea ice? So we talk about the first event being a blue ocean event. You know, so maybe within 5 years we won't have any sea ice in September. Anyway, think of what's going to be up there. The only cold area up there with no sea ice is obviously Greenland. The center of Greenland is 73 degrees north, latitude 73 degrees north. So it doesn't take a big stretch of the imagination to think, okay, when there's no sea ice in the Arctic at all, why would the jet streams continue to circulate about the North Pole? No, the center of cold is the center of Greenland, so the jet streams will circulate about Greenland, and therefore not only do the jet streams slow down and become wavier, but the entire nature of the jet streams will shift. They're going to be offset from the North Pole towards Greenland, bringing much more powerful ridges of cold down over North America, and completely, you know, the circulation system of which is the atmosphere and the oceans, are basically going to be rewired. And this is a huge problem to all of humanity, because we have to grow food. And it's going to completely change our ability to grow food in different regions. Regions where we could grow it before, we will no longer be able to grow it. In fact, many areas of the planet will start to become uninhabitable, basically. And we talk about uninhabitable regions on Earth. People think mostly of places like the Middle East, for example, where the Red Sea or something is approaching that 35 degrees Celsius temperature, and when it reaches that temperature, the weather conditions along the coast are 35 degrees Celsius or higher with 100% humidity, and this is a wet bulb temperature. This is the limit of human survival. So people won't be able to live outside or be outside for more than 6-8 hours before they get heat exhaustion and heat stroke and die if they're not brought into colder conditions. We also can talk about maybe some Caribbean islands becoming uninhabitable. You know, what happens when the jet streams are so slow that the Category 5 hurricanes meander along and actually stall over a Caribbean island, like Grand Bahamas or Abaco Island, for example. You know, and we have hurricane force Category 5 winds over a Caribbean island for 2 days solid. I mean, no infrastructure can survive. So what are a couple other things? Well, obviously Greenland. It doesn't take a rocket scientist or a climate scientist to realize that with no Arctic sea ice and a much warmer Arctic, that the melt rates from places like Greenland will greatly accelerate. In fact, the doubling period, every about 9 or 10 years, the melt rates from Greenland and Antarctica double. And this has been happening for many, many doubling periods, you know, at least the last 2 decades. You know, this was in a famous James Hansen paper. So if you continue that rate, well, obviously, you know, no sea ice and a much warmer Arctic, you know, there's nothing going to be stopping Greenland melt rate. It's going to be greatly increasing. And also, we have the big methane situation. We have lots of methane in the eastern Siberian Arctic shelf. The water's shallow. It's only 50 to 100 meters deep. And the sediments on the seafloor get perforated and we're getting methane bubbling up from those areas. We're getting lots of methane coming up from the land permafrost. Look at the Siberian Yadoma Peninsula. We're getting huge craters being formed by methane coming up, causing explosions, and people are reporting, bursts of light in the distance and so on. So these things are all feeding back, and I guess the point is we're not always going to be, we're losing control of our ability to actually do anything about it. If the more we talk about doing something and do the least, then we're losing that window of opportunity to make huge change without completely revamping everything. Because as the ecosystem changes, the emissions increase from the Earth itself, and those will dwarf any human emissions. Just one last point. There's 5 gigatons of methane in the atmosphere right now, total. And if there's a 50 gigaton burst of methane, as Peter Wadhams has discussed in a paper a few years ago in the Arctic, that would increase the level of methane in the atmosphere by a factor of 10. I mean, we're talking about huge amounts of methane in the permafrost and tundras. So we can't, there are people that are talking about climate restoration ideas, and a big part of climate restoration is, can we cool the Arctic? So yeah, we have to slash fossil fuel emissions, but that's not sufficient. We also have to pull CO2 out of the atmosphere, and we have to deploy technologies to try to cool the Arctic and keep the order in our weather patterns and systems intact, so that we can continue to grow food on this planet. Thank you.
Yeah, so actually you brought up, can you guys hear me? You brought up a few, I have some questions in regards to some of the things that you brought up. And one of them is you spoke to the emissions and the gigatons and the wavy and the this and the that. And what I really would like to know is, what does all this mean for example, for Spain? What can people in the south of Spain expect within the next 20 or 30 years? Certainly it will affect people right here. Can we bring it home to them? How will their lives change?
Okay, so that's a great question. Spain and a lot of Europe endured some major heat waves again this summer. In 2003, we had 70,000 people in Europe killed, mostly in France, from heat waves. What happened this last summer is, you can follow it clearly. If you go to a website like Earth Null School, N-U-L-L School, you can actually look and see what happened. And the heat built up over the Sahara Desert, and that heat dome crossed the Mediterranean. So it's very dry in the Sahara. So you get a massive heat dome over the Sahara, very dry. Then it moved northward and it crossed the Mediterranean, picking up moisture as it went. Then it hit Europe with the heat and with the moisture. So you can see this ridge of the jet stream moving right up northward into Europe, bringing that heat wave. So there's a strong possibility that heat will become more of a permanent situation. And if that's the case, then Spain will be Sahara Desert North, basically. Okay? Very much drier place.
So right now, as we know in our current political, socio-geopolitical era, Spain has been taking on a lot of climate migrants. And what it seems that you are suggesting is that the Spaniards themselves may be the next climate migrants in line.
Yes, many people will become climate migrants, and they have no idea or no expectation of that happening. One of the problems is, you can already see it in Spain, with a lot of the migrants from Africa coming over into Spain. Okay, within Spain there can be a populist sort of backlash against having so many migrants. These populist backlashes tend to lead to right-wing governments who want to build walls and keep immigrants out, basically. So we're seeing this is a very, very powerful human tipping point, human feedback, which makes climate change worse, because as you get more and more right-wing governments that are against the immigration of people from climate immigration, climate migrants, then they get the right-wing governments also deny the existence of climate change. So any climate policy that Spain has may be just completely destroyed by the stroke of a pen. This is always a problem. It takes a lot of time to set up policy and to do work to cut emissions, but a right-wing government can come in on day one when they're elected with the stroke of a pen. They can destroy everything that the previous government has done. So stuff is destroyed a lot quicker than it's created.
Wow, that's a powerful lesson in karma, actually. Do unto others, I suppose. I just have a question for you. Actually, Peter, I had a question in regards to the Arctic. How do you get people to care about the Arctic? When they see the Arctic, they see ice, they see nothing there. How does it relate to people's lives? Why should they care?
Okay, well, you get that phrase, what happens in the Arctic doesn't stay in the Arctic. People need to realize that. But I think we have to move to Peter here in his slides.
That was his...
Okay.
Okay, back to the Arctic. What you're looking at is the Arctic on the 9th of July in this year, 2019. And this is satellite data, which is interpreted to show the sea surface temperature. So the red is a high sea surface temperature and the blue is cold. So you can clearly see this big tongue of warmer sea surface encroaching further and further into the Arctic. Now, the millions of square miles of Arctic summer sea ice is a reflective shield against the sun's heat for the frozen Arctic and the temperate northern hemisphere. That's the physics of the thing. Therefore, the Arctic sea ice and the frozen carbon that has allowed until recently to stay frozen has allowed, in fact, the amazing richness of life on Earth on which we live and enjoy to flourish. That's the Arctic sea ice. It's also, the Arctic sea ice has also allowed the great success of Northern Hemisphere agriculture. What you're seeing here is 2019 global warming. This is from the World Meteorological Organization, published just last month in November. So that is the 1+ degree C of warming that Paul referred to. But these maps show dramatically that the fastest warming is occurring over the permafrost of Alaska and Siberia. The temperature limits, the 1.5 degree survival imperative, and 2 degrees C in fact, triggers multiple Arctic inter-reinforcing feedbacks. And these also become planetary tipping points. These feedbacks amplify global temperature increase, which leads, if we carry on with the insanity of those emissions, which inevitably leads to an irreversible hothouse Earth and runaway. So the Arctic is being heated faster than anywhere else, and this is the latest on that temperature. This is from the NOAA, December of 2018, and you can see that here from 1900 up to 2019. But if we look at it from 1980 to 2019, just look at that graph. Look at the dramatic divergence of the Arctic temperature and the global temperature. And as the global warming increases, so does the divergence. So the Arctic temperature is accelerating faster and faster and faster. So there's an image from the Climate Emergency Institute that shows the catastrophic loss of Arctic summer sea ice. You see on the left of my image the intact Arctic, and you have Arctic cooling and Northern Hemisphere temperate, because that is the air conditioner of the entire Northern Hemisphere. On the right you see an image in which all of that Arctic sea ice is being removed in the summer, and instead of cooling, you have heating. You have exactly the opposite. There are multiple enormous Arctic sources of feedbacks that amplify temperature, and as I've said, these are planetary tipping points. And there's one image of them. So the feedbacks are Arctic sea ice in the summer, Arctic snow in the spring to summer, wetlands in the subarctic, permafrost in the Arctic, the boreal forest, and so there is a lot of Arctic feedbacks which have already been triggered by our uncontrolled global warming. There's a fairly simplified polar view of the enormous Arctic sources of carbon feedback emissions. In the dark brown there you see permafrost and subarctic wetlands, and they hold more than double all the carbon in the atmosphere. There's a more complicated image, I won't go through that, but enormous Arctic sources of amplifying feedback. So there you see the map of permafrost. The purple is permafrost, and the vast amounts of permafrost, particularly in Siberia. There's 9 million square miles. There's 9 million square miles of permafrost in the Arctic, and left with the Arctic sea ice intact, and right with the Arctic sea ice gone. So this is an illustration showing Arctic feedback tipping points, the domino effect, the hothouse Earth. Actually, the world-leading Arctic expert from Spain, Carlos Duarte, published excellent papers on these. And this shows we have sea ice melt, pushing snow cover melt, pushing warming wetlands, pushing thermal thawing permafrost, and eventually also pushing subsea methane. This is a planet-killing situation, right? Now I'm going to go over 2 very important 2019 Arctic research papers very quickly that are crucial to a livable planet for today's children worldwide and to all of us, our common future survival, or humanity and all life on the planet. 2 papers. The first one on when will the summer Arctic sea ice disappear, according to this one as early as 2045, but actually I'll show you the image next and you'll see it's quite possible that Arctic summer sea ice will have disappeared for part of the year, September, by 2030. People, that's no time away at all. And the second paper is one that shows and calculates that the loss of Arctic summer sea ice is equivalent to another 1 trillion tons of carbon dioxide. You put those 2 papers together, we are on a route to oblivion. There's that image where you can see that there actually is projected from these models a collapse of Arctic summer sea ice after 2020. Maybe you can see that. So here's runaway. There are multiple Arctic reinforcing global warming feedbacks. They are cascading. They push each other harder and harder and harder. That leads to hothouse Earth. Hothouse Earth leads to runaway global heating and climate chaos. And that circular situation that you see there, that's the ultimate vicious cycle, and it goes on and on and on. And it's a runaway, and we have to stop our global warming emissions in order to avoid runaway. Greta Thunberg was right. She's right by the science of the Arctic in particular. Her emissions have to stop. This shows permafrost. This is another recent paper of this year, 2019, and that shows how Arctic permafrost temperature, you're looking at permafrost temperature, suddenly increased in 2014. I'm sure you can see that. Currently, thawing permafrost is emitting methane, it's emitting carbon dioxide, rather a lot of carbon dioxide, and it's emitting nitrous oxide. All 3 main greenhouse gases are being emitted as feedback from the Arctic, which is adding to our own constant greenhouse gas emissions. So the Arctic has switched from a net carbon sink to a carbon source. That is a dramatic change for the entire planet. That was reported first by the NOAA in 2016. 2 papers have since been published that confirm that the Arctic is no longer sinking carbon on a net basis. It is now a source of carbon. And as long as we push that Arctic amplified temperature higher and higher and higher, the Arctic is going to be a greater and greater source of carbon, both as carbon dioxide and as methane. That's an illustration from the report. So now Arctic planetary tipping points. So there's an illustration of that. Have a time up? I will finish. Thank you.